Alright, on to the fourth method. Remember, graphing, factoring, and square rooting all have limitations. Graphing isn't very accurate, and it sucks to graph things. Factoring obviously only works when we can factor something. And then square roots only work when b equals 0. The next two methods we're going to learn are the most time-consuming and probably the most confusing, but they both work all the time. First one we're going to do is something called completing the square. Again, this works every single time. It's just a little confusing. But what we're going to be doing is actually completing a square, making a square out of our variables. So let's say we start with this equation up here, x squared plus 2x equals 0. So if we take that equation, we can factor it, we can pull an x out, set them both equal to 0, and we get two answers, x equals 0, and then x equals -2. So those are our answers. Now we're going to do this a different way. Obviously factoring is the way you should do that, one problem. But some of these problems we're going to do cannot be factored. So we have this square here, and let's fill it in to match our equation. So we have the x squared part. Remember that it's like area. So x times x would give me x squared there. And now I want to split this guy up. I can't put all 2x here and all 2x there. So I'm going to put 1x here. So that means this thing would have to be plus 1. And then put one of the x's here. So this would have to be plus 1. If you remember this from the frogs and fleas, hopefully that makes a lot of sense. And then what would go in the last box there to complete the square? Well, we would have to do 1 times 1, which gives us 1. And we can't just go adding things to an equation and still have it equal 0. So what we're going to do is say, I'm going to add 1 to the left side of my equation, down here, x squared plus 2x plus 1. And then also add 1 to the other side of the equation to make it equal. So remember, if I just subtract this one, I end up with what I originally started with. So we're not changing it, just changing the way it looks. So now this expression here is factorable. And the awesome thing about this is when we factor it, we end up with a perfect square. Look back up here to our factors. We have x plus 1 times x plus 1. Or we could write that as x plus 1 all squared. That's the whole point of completing the square. And instead of equaling 0, because we added 1 on the left side of my equation, it now equals 1. And now we can do exactly what we did yesterday and solve this by taking square roots because it's a perfect square. So remember, this right here means that I have x plus 1 times x plus 1. So to get rid of that other one, I can take the square root of both sides. So the square and the square root cross each other off, and I get x plus 1 equals, don't forget things from before, we need plus or minus 1. So now we have two equations technically, and I think it helps to write our two equations. We have this x plus 1 can equal positive 1, or x plus 1 could equal negative 1. Remember, that's two options. And then solve. Subtract 1 from both sides here. So one of my options is x equals 0, which we knew from back up above. And subtract 1. My other option is x minus 2. So I know, way more work than just factoring it, but sometimes it won't be factorable, and we'll have to do this completing the square. So let's go over those rules again. The procedure for completing the square. Write the equation in the form x squared plus bx plus something equals c, equals your constant. So we put it on the other side. And then we have to remember whatever we add to one side, we have to add to the other. So we complete the square with half of b. If you look back here, this is not a coincidence that if you cut 2 in half, you get 1. Which is what goes in the square. That will happen every single time. That's what we add to both sides of the equation. So we take b, we cut it in half, and then we square it. That's what goes here and here. Factor the perfect square trinomial. You only need to find the principal factor, so leave it as this. And then take the square roots of both sides. In this step, you need to make sure you take both square roots on the right side. So that's where you need the plus or minus. So let's look back at the square analogy. Here's our square right here. X squared term always goes in the big box. We got to take b and cut it in half because we need to see it twice. And then remember, we're going to multiply to end up with our constant. And that's what we're going to add to both sides. So let's do some problems, start to finish. So A, this one's set up kind of like we want it. We have x squared plus 6x plus some blank equals 0 plus a blank. So, in order to figure out what that blank is, we can think about a square, and then remember that we're going to have to factor it into a perfect square. So what I always do is I kind of skip a step and say, we know that this is always going to be x. Now take this b part right here and cut it in half. So b cut in half would be plus 3. Because remember, we need 2 of those long stick parts. One's going to be 3x, the other one's going to be 3x. And then square that to get this number up here, which is 9. Because remember, when we make our box, this part's x squared. We got to cut that b in half, so this part would be 3x, and this part would be 3x. So that means this had to be x plus 3 times x plus 3. So to get that constant, you do 3 times 3, or 9. Now this is pretty confusing, but remember, if you added 9 to the left side, we have to add 9 to the right side. So we end up with, let's just rewrite this, we get x plus 3 all squared equals 9. And now this is something that we can solve. Take the square root of both sides. We get x plus 3 equals plus or minus 9. Be very careful here that you don't subtract 3 from both sides and then say that your answer is plus or minus 6. Remember to split this up into 2 problems. So you get x plus 3 could equal positive 9, or x plus 3 could equal negative 9. And when you subtract 3 here, you get 6. But your other option here is negative 12. Let's do b together. Let's move it to a different page so we have a little more room. We want to first rewrite it with this 7 on the other side. Because this right here doesn't make a perfect square. So if I subtract 7 from both sides, this is what I end up with. And now I want to turn the left side into something perfectly squared. We know x is always going to be right here. And the number that we add, remember, is half of b. So you take this number and you cut it in half. In this case, it's 4. And then remember, when we factor this out, we would end up doing 4 times 4, or 16. We can't just go adding 16 wherever we want. So if we added 16 to the left, we have to add 16 to the right. And then negative 7 plus 16 gives us 9 again. So then hopefully once we get to this part, it's a piece of cake. It's just getting to this part that's a little tricky. We got to take the square root of both sides. So we get x plus 4 on the left equals plus or minus 3. Again, don't just subtract 4 and tell me that it's plus or minus 1. We need to set this up into 2 equations. X plus 4 could equal positive 3, or x plus 4 could equal negative 3. So now I want to subtract 4 from both sides. So here's one of my options. X could be negative 1, or x could be negative 7. Let's do C. C is written a little better than B was. We have the 15 moved to the other side, but let's rewrite it so we have a blank equals negative 15. So now remember, we want to factor this into something that's a perfect square. So we know x is going to be the first thing. What goes next to it is this b cut in half so that we can make two of the same sized squares. So we get plus 8. And then remember that we would end up doing 8 times 8, or 8 squared, so that gives us 64. If I add 64 to one side, I have to add 64 to the other side. So negative 15 plus 64 is going to give us 49. Love it when it's a nice perfect square. And then we can take the square root of both sides to solve. So I get x plus 8 could equal plus or minus 7. Split it up into two possibilities. This stuff could equal positive 7, or this stuff could equal negative 7. First one, you're going to get negative 1. Next one, we're going to end up with negative 15. Those are our two possibilities. Now, all of these have been factorable. Realize that. But completing the square is something that you need to know how to do. So right now I want you guys to try D and E on your own. Pause the video and let's see if you can do it by yourself. So for D, when you completed the square, you got something that wasn't a perfect square, which is totally okay. We already approximated the square root of 10. We know that's about 3.16. So we have plus or minus that. We can solve for x, and your two possibilities are x could be 5.16 or negative 1.16. Remember, you can always plug these back in and make sure that they work. E, on the other hand, is a bit of a trick. If we were to subtract 15 from both sides, we end up with negative 18. Totally okay. But when we complete our square, the number that we add to both sides is only 16. So because of that, we end up with a negative 2 that we're trying to take the square root of, which is totally not possible. So the answer for this is no solution. Now the next couple problems that we're going to do have a leading coefficient that's not 1. This cannot happen. So what we need to do is divide everything by a. So let's do a together. We have 3x squared minus 10x minus 3. Can't happen. So what I need to do is divide everything by 3. It's going to be a little messy, but that gives me x squared by itself. Leave this as a fraction. Do not turn it into a decimal. I know it's tempting. Remember, we got to leave ourselves a space here, and then it equals negative 1. So steps are exactly the same. I want to turn this into a perfect square. I need to take negative 10/3 and cut it in half. So remember, taking negative 10/3 and cutting it in half divided by 2 is the same thing as multiplying by 1/2. Way easier to do, and we get negative 10 over 6, which can be simplified to negative 5/3. So that's what goes right here, negative 5/3. Because all we did was cut this in half, divide by 2. And then remember, to get the number that goes back up here, we need to take our b cut in half and square it. So negative 5/3 times negative 5/3 gives me 25/9. And that's what I'm going to add to the other side. So if you add up negative 1 plus 25 over 9, we can think of this as negative 9 over 9 plus 25 over 9, which gives me 16 over 9. So that's what it equals over here. We can take the square root of both sides. We end up with x minus 5/3 equals plus or minus 4/3. And then all we have to do is split this up into two equations.